All right, if you've been keeping an eye on the absolute explosion of autonomous AI agents lately, you already know we're right in the middle of a massive paradigm shift. But here's the twist. We're actually moving away from those massive do-everything AI applications, and instead, we're heading back towards something incredibly foundational.
So ask yourself, why on earth is a 50-year-old operating system blueprint suddenly saving modern AI? I mean, it sounds completely counterintuitive, right? We're dealing with bleeding-edge artificial intelligence, yet the single most effective architectural solution we're finding right now perfectly mirrors the design principles of the 1970s. It's absolutely fascinating.
Here's the quick roadmap for today's explainer. First, we'll look at the monolithic AI trap. Second, the Unix philosophy revival. Third, small models and sharp tools. Fourth, text as a universal interface. And finally, we'll see why the future is composable.
Kicking things off with Section 1, the monolithic AI trap, or as I like to call it, the collapse of the do-everything system.
Just to make sure we're all on exactly the same page here, unlike your traditional generative AI that just kind of sits there waiting reactively for a prompt, agentic AI proactively initiates actions. We're talking about a system that orchestrates complex, multi-turn workflows. It fundamentally moves beyond just being a helpful chatbot and becomes an actual autonomous system executing multi-step strategies.
But man, getting to this point has not been pretty. Back in 2023 and 2024, the industry tried to build these massive, monolithic frameworks. Think LangChain or AutoGPT. The idea was to just let a single large language model do absolutely everything. Planning, execution, evaluation, the whole shebang. And the result? Extreme bloat. We started seeing infinite execution loops, where an agent would just endlessly check its own flawed output, racking up exponential API costs literally overnight. And because LLMs lack true self-reflection, a tiny error in one little subtask would amplify, like a snowball rolling down a hill.
Which brings us to Section 2, the Unix philosophy revival. Because hey, history repeats itself. You know, the tech industry has literally made this exact same system design mistake before. Back in 1965, there was a project called Multics that attempted to build an operating system that did absolutely everything. And shocker, it grew ridiculously bloated and collapsed under its own weight. In response to that, by 1969, researchers at Bell Labs built Unix on a scrapped PDP-7 machine, entirely focused on extreme simplicity and modularity. Fast forward to 2023, we repeated the Multics mistake with massive LLM frameworks, and right on cue, by 2025, the AI industry started mirroring that 1969 Unix rebellion, pivoting hard toward lightweight CLI agents and small language models.
And honestly, this whole pivot is perfectly captured by this legendary 1978 maxim from Doug McElroy, the guy who actually invented the Unix pipe. He said, "Write programs to do one thing well, work together, and handle text streams, because text streams are the universal interface." This 50-year-old philosophy perfectly validates the exact frustration AI developers are feeling today. Instead of one massive AI doing a dozen things poorly, we just need focused programs working together.
Moving right along to Section 3, small models, sharp tools. The classic less is more motif.
So, let's talk about small language models, or SLMs. These are models under 10 billion parameters that run locally, and they are highly optimized for specific, repetitive tasks. Think of SLMs as the brand new Unix utilities. Just as Unix has grep for searching and WC for counting words, we now have specialized SLMs that achieve incredible performance on really narrow tasks, but they operate at a sheer fraction of the cost and compute of a massive generalist model.
When you look at them side by side, the contrast is actually pretty wild. The old monolithic AI paradigm relies on generalist LLMs that are slow, expensive, completely trapped in complex frameworks, and tied to centralized cloud infrastructure. The modular AI paradigm, on the other hand, uses specialist SLMs. They're lightning fast, incredibly cheap, and run as simple command line tools right on decentralized edge devices.
And look, this shift, it's 100% intentional. Boris Cherny, the creator of Claude Code, specifically noted that Claude Code should be composable just like grep or cat. He literally said it should be able to be combined with other tools. It's deliberately designed as a bare-bones terminal-based utility. It is not a heavy, bloated IDE. It is a sharp tool meant to be snapped together seamlessly with other tools in a pipeline.
Next up, Section 4, Text as Universal Interface. We are returning to the basics.
So why plain text? I mean, it sounds so primitive, right? But it's actually incredibly powerful for a few key reasons. First, it's the native language for LLMs. They parse standard markdown infinitely better than some complex, deeply nested JSON. Plus, text can be diff managed with Git, meaning we can track every single change over time. It's completely readable by humans, which is absolutely crucial for debugging. And most importantly, plain text flows effortlessly through Unix pipes from one tool right into the next.
Let's look at this in action, because the modern agentic pipeline elegantly mimics a standard Unix flow. Step 1. Find your target files using simple tools like glob. Step 2. Search for specific patterns using grep. Step 3. The LLM reads that plain text output. And Step 4. The LLM writes its response or code. That's it. Only text streams pass from the tool to the LLM and back. It is just so clean and incredibly fast.
Now here's where it gets really fascinating. Developers are actually starting to abandon RAG, Retrieval Augmented Generation, for basic, primitive stuff like glob and grep. Why? Well, lots of developers found out the hard way that complex vector databases were essentially black boxes. If the AI hallucinated or grabbed the totally wrong context, good luck figuring out why. By stripping away those abstract layers and just using plain text search tools, developers can actually literally see the execution process step by step. It makes the entire AI system highly transparent and debuggable.
All right, bringing it home with Section 5. The future is composable, connecting the new ecosystem.
At the very core of this composable future is MCP, the Model Context Protocol. It's a standardized, extremely thin protocol for LLM agents to interact with external tools, and it relies entirely on, you guessed it, simple text-based streams. Think of MCP as the digital glue of this new era. It enables completely lightweight interoperability between totally different models, data sources, and tools, all without needing some massive, heavy framework holding them together.
And when you actually build on that kind of reliable, text-based foundation, something amazing happens. Agentic AI fundamentally alters human oversight. By relying on pipelines that are highly modular, totally transparent, and perfectly debuggable, we can actually finally trust the AI enough to grant it complete agency in its autonomous execution. It graduates from being this brittle toy that needs your constant supervision into a highly reliable colleague.
Let's do a quick recap of this core shift we're seeing. We are moving away from do-everything architectures over to piped, small tasks. We're moving from complex vector databases back to primitive, transparent tools like grep and glob. We are leaving behind bloated frameworks for thin protocols like MCDP. And we're trading those UI-heavy, rigid dashboards for the immense raw flexibility of the CLI-based terminal. It turns out, removing the abstract layers actually makes the AI smarter, more agile, and way more reliable.
Which leaves us with a pretty important question for your own technological setup. What bloat can you trim from your own AI workflows? Because as we've seen today, the absolute smartest path forward isn't adding more complexity. It's going back to that proven 50-year-old philosophy of keeping things simple, modular, and composed of really sharp, well-defined tools. That's all for today's Explainer. Thanks so much for joining me, and I hope this helps you build leaner, smarter agents. See you next time.